over to you.
Thank you so much, Maria. Thank you for having me. Thank you for organizing this. We are going to speak about my favorite topic, reference architectures at the moment. And again, please feel free to ask questions. We are monitoring the questions here. Great to see people again joining from all over the world. This webinar is slightly more specific in its technological focus because it's focusing on the GCP ecosystem. That said, a lot of the different tools that we're using and the general logic really is applicable to any cloud and multi-cloud. I can only echo what Maria just said. The actual makers are going to speak at PlatformCon, at I think even GCP's flagship event, and at other events, and they're going to actually show this reference architecture again. I played my small part in the development of this reference architecture, or these reference architectures. There are actually several architectures, and I want to speak today about what architectures are and what the design principles are that we actually follow designing them. And we're going to have a look at one, and then we're basically following a deployment, conceptually all the way from A to B, really through such a platform. And then I'm happy to take questions. Last time I heavily ran over, and Maria said that I'm supposed to not do this again today, so I'll do my best. All right, so again, making off, so how do we develop? I want to quickly look at this, the problems we aim to solve, and then the design principles that we applied, and then we're looking at the design, and then I'm going to give you a conceptual end-to-end walkthrough. Now, note that there is also a white paper specifically on GCP reference architectures that we are going to share afterwards via email. But this is really, I think I wrote the white paper a couple of weeks ago. So since then, I've seen this reference architecture already rolled out and trialed, or in prep for rollout at several large teams again. So I've really gathered new intelligence, if you want, and I'm going to give you the latest of this. Okay, so we developed those reference architectures for pretty simple reasons. I've been spending the last years bullshitting about platform engineering, but I've not really been super concrete about what I actually mean. I'm not sure how many podcasts I were on where I was asked what's an internal developer platform, and I always gave a definition that was sort of okay generally, but it didn't really mean much. And so this is about really making it concrete. And so more or less what we're doing, or what we did, is when we started 4 or 5 years ago, actually, trying to make this platform trend more mainstream. We had built platforms basically since the early 2010s, but this really started to be a little more of a movement, I would say, 4 years ago, maybe. And the simple fact that we didn't do that was because we had only seen so many platforms, maybe a dozen, couple dozen, maybe. So if you don't have a lot of data, you can't really say what good practice in platform engineering is, right? You feel that there is something, but you can't really articulate it. So now we actually have a lot of data. So, to give you a feeling, we have around 10,000 signups to Humanitec's orchestrator alone, and then not all of them build a platform, but that means we're seeing a very large set. But even that was maybe not enough. But then McKinsey came along and said, guys, we really see a lot of platforms. McKinsey has an excellent platform engineering group that can really help, drive strategic decisions and help you implement platforms at scale. And then they started to say, okay, you know what? We are going to take this on, and we are going to build reference architectures, actually taking all the learnings that we had from, at this point, really dozens, hundreds of platforms that we looked at, and say, okay, what are repeatable patterns here? It started with Amazon Web Services. this GCP one that we're looking at today has actually finished 4 days ago, the actual code. It's brand new, and this is eventually going to be open sourced, and it's going through some compliance checks now. We're already using it in workshops, and we're using it with people that are interested. And if you want to see it, you can reach out to me and we can give you access, but we don't have the licensing stuff figured out yet. So or McKinsey doesn't have the licensing stuff figured out, what open source license, and so this will take a while. Anyhow, so let's first look at the problems that we want to solve. And I think it's great to think about this, that we want to get engineering teams from overwhelmed to over-delivered, right? I believe the key things here is long lead times, ticket ops, high cost of maintenance, developers that are overwhelmed, missing self-service, waiting times. And it's a lot of these small things. It's, our CTO calls it death by 1,000 paper cuts. And I think this is very well put. There is this general feeling that your DORA metrics could be improved and that everything is too slow and there is so much back and forth. And many teams have literally just given up, right? They've just said, that's how it has to be. And the good news is that's not how it has to be, right? If you have great platforming setups, there is very little waiting time, and you can yield tremendous results, and you can have very good outcomes if you apply these things in a more structured way. And the core driver here is standardization, and to a certain degree, separation of concerns. If you have follow the mantra that everybody has to do everything, right, that will not fly. And I understand the emotional idea behind everybody's able to go down to the lowest level of configuration. But if we look at the reality, right, of how this has played, this has just not really worked. And I'm not advocating for shutting people out of stuff. I'm advocating for the more standardization you have. It's a very simple formula. The more standardization you have, the easier your systems are to maintain, the easier they are to use, the faster you will be, and the less friction you'll have in the team. So the question is, how do you design systems that follow those principles? And I want to look at the principles a little more. Now, for me, the key thing that clicked was that idea that if you don't start to treat every single release like day zero, you will not get anywhere. What do I mean by this? Many people think about platform engineering where they have a nice user interface, and then there is a button where it says, I want to have a new Spring Boot service, and then in the description it says this has also a database, and I don't know, it's running on a namespace. Yeah, that's from a technological perspective, nothing very special. This portal then calls the service, the templating API from GitHub, maybe clones this, executes a couple of GitHub action steps, and then you have your service. That is not actually what's driving the return on investment, and that's not actually solving the actual problem. We need to think about these things much more holistically. And the key, in my opinion, from an architectural perspective, is that we need to dynamically create the app and infrastructure configurations every single release. And this will sound a little strange that I'm hammering in on this very specific point, but I really believe that this is the silver bullet. Because all of a sudden you're treating every single day like day zero. It's as if you are scaffolding every time you git push. That allows for a very high degree of standardization. That allows for separation of concern without actually taking context. And that actually then leads to all of the benefits. The key benefits that your managers care about is none of what I just talked about. They don't even know about this. And they will not know today, and they'll not know in 5 years and not in 10 years. The thing that they care about is that you slash your lead time. And they don't even care about that because they don't know what that means. They care about their time to market. They want you to deliver more to the market faster. Okay, so before we actually go into that design principles, let's look at what is a reference architecture. Well, we started with simple flow diagrams. I'm going to show you that, but then we actually continued and packaged everything as code. And it's one design principle that we're going to look at. We believe that platforms need to be packaged as code. Those are integral systems to your delivery flow, and there is no reason. And there are products, right? You know, we have that mantra of treating our platform as a product, and there is no reason why we shouldn't apply all the normal software engineering standards when we are building this product. And that means this product needs to be testable, and that means that product needs to be available as code. And so those reference architectures are literally packaged platforms as code. You know, we have white papers, we were writing, I think McKinsey's writing tutorials, and that's good and fine. But the core really is that packaged code. And it's a starting point, right, for teams to say, okay, well, how could that look like? What could the experience be like? And then localize that to your own needs, because the reference architecture is a reference, right? And how your specific internal developer platform looks heavily depends on your security posture, the number of developers, your workflow, and all of these different things. Cool. All right, let's look at the design principles. And I want to highlight 4. And I want to start with golden paths over cages. Now, that's another thing that I'm saying over and over again. I'm going to be very specific what I mean by golden path during this conversation. But I believe it's important to really look at that principle, because the platforms that we've built in the early 2010s were very, very restricted. I had a conversation yesterday in a YouTube live with some people at bull.com or something. And the woman that built the platform said something very interesting. They were way too restrictive and too abstract in the way they actually built this. And that leads to a lower range of adoption, right? You want the developers, you want to offer them golden paths, but a golden path means you can leave it, right? So no golden cages, golden paths. Now, it's fine to abstract developers, but you can never do that at the expense of context. So one thing that the platform at Google, for instance, was very good at, and I don't know whether you know that, but you know, a lot of my colleagues come from the Google platform world. They were very good at providing abstractions that provided context. So as an example, you would say, I don't know, this workload needs an S3 bucket. And it wouldn't just go into the ether and then something miraculously happens, but that would say, okay, well, this command will lead to this exact config to be executed. Are you okay with this? Can you have a log? You know, and then you're either able to go low level, and then, or depending on the security posture, you know exactly what team to speak with. On the second element I already looked at, that's then dynamic over static configuration management, and I can't stress that enough, really. If you believe your job is done, if you figured out the scaffolding workflow, then that's just not the case. Your job isn't done. We need to think about standardization with every single deployment. It is not enough to think about day 0. You need to think about day 100, day 1000 of the application, because this is where we're really driving home the return on investment. This leads to standardization by design. So this is sort of really a design choice. You want to design systems that by using them, the degree of standardization stays constant or actually increases. And none of the systems that you are probably running today follow that paradigm. From the situation you start a service, it starts drifting in between environments, it starts drifting in between sort of the resource configurations and the baseline templates. And that's not standardization by design. But if you want to achieve this, this remains very important. I highlighted this code first. So we want to have testable platforms. But that goes beyond the simple testability in the platform design. I think it also has something to do with the interface choice. We're going to look at this a little bit. If we are really honest and we're looking at the data, then any interface we are adding to the developer workflow is perceived as a distraction and usually sees low adoption, which is why I am heavily advocating for code-based interfaces. Although I also believe that you need the right horse for the right cause. So you should leave the user the freedom to choose the interface based on the circumstances. So what you will observe in usage is that in 98% of cases, it will be code-based and everything else will be fully automated through the pipelines. And then some people, depending on the preference and depending on the situation, will use user interface for automation, sometimes, I don't know, CLIs or APIs. But if you just look at all of the deployments that could possibly happen, like the majority of the interactions between the developer between the user and the platform, that will probably, you know, be in code. So the more you can keep people in code, the higher the adoption. And I have seen so much usage data now. Trust me, that is really important point. All right, and here we are. This is an internal developer platform on GCP, a reference architecture for IDPs. And for now, a lot of logos, and you're confused, and that's fine. I'm going to give a little bit of an orientation here. So let's look at the planes first, because I think McKinsey did a terrific job in actually explaining this concept based on planes. And the first plane is the developer control plane. And this is where both user personas, the developer, the platform engineers, are interacting with the platform. Now, you could use, we will definitely have a version control system, right? In this case, we have GitHub. And then in GitHub, we have, we're using Terraform for infrastructure as code. And then we are using a workload specification. And that's an important component to enable that dynamic configuration management, because it's an abstract way for the developers to describe the relationship between workloads and dependent resources. And given that abstract request, basically, the platform knows how to generate the actual app and infrastructure configurations. We're going to look at this in just a second. And then we have a service catalog or developer portal. There are several names out there. And in this example, we're using Compass by Atlassian. The Amazon example uses Backstage. Now, why are we using Compass in this case? Just because, you know, we want to show a little bit of variance. I'm, you know, a fan of both. If you are in the Jira world already, I think Compass has a fantastic architecture. And the portal is about, you know, visualizing stuff, looking at things, searching services. It's a user interface layer, right? With that helpful. I would say it's helpful if you have, let's say, more than 200 developers. Less than 200 developers, you know, I have my questions whether you'll really see, you know, something that would justify the investment. But from 200 developers onwards, definitely something to consider. Then we have the integration and delivery plane. Now, this is where stuff gets built and generated, really, you know. We have CI pipelines, GitHub Actions in this case. It's worth noticing that you can take any of those brand names and just change them. We could have Jenkins here or Circles here. It doesn't really, you know, matter. We just use the stuff that is most used, to be fair, in the context of Google ecosystems. Now, then we have artifact registry as the registry, again, interchangeable. We have a platform orchestrator with Humanitec. We have a CD pipeline with Argo CD, I'm personally a big fan of. And then that is the integration and delivery plane. And then we have the resource plane. You know, this is where our, you know, resources, this could be anything. In this case, we have GKE, and then we have CloudSQL, and then we have Cloud DNS. And I think we have, you know, file storage as well. The monitoring and logging plane is not so much a focus of this, but can be wired in the APMs. And then you have the security plane. And I think in the Google world, this is called Secrets Manager or whatever, could also be HashiCorp Vault. In reality, at the enterprise scale, there are more things on the security plane, like policy checkers and stuff like that. So this is a little bit simplified, but it gives you an idea of the direction. I want to dive a little deeper into the developer control plane here. We have the service catalog and the version control system. And the first thing that I want to look at is the interface choice. And the answer is, well, it depends, right? What are you using? For the deployment of something, in 99% of cases, it's a git push terminal or IDE. To change configurations, you'd probably use this code-based with a workload specification, whatever that may be, to add and remove resources that you have a running service and now you need an S3 in all environments. You would add that as code, throw that at the pipeline, and it would generate the right thing in the right place and wire everything up. To rollback or diff, this can either be done in the API CLI or UI of the orchestrator, or you build this into the portal layer. To configure resources in detail, probably infrastructure as code, Terraform or cross-plane or the like. To spin up a new environment, again, API CLI or UI, or you build this into the portal. Logs and errors is the same. Search a service catalog, so the search thing, that's definitely a portal thing. Inner source use cases, definitely a portal. And then the scaffolding use case, that's a portal, or sometimes, it's just enough to use the templating API of GitHub. Always something that I would consider first. Good. Now, the workload specification is an important element here. In this example, we're using SCORE, open source. Let me be very transparent. I was heavily involved building this. There are other options you can look at, but it's open source, no intention whatsoever to monetize this. And I think at this point, 8,000 stars, really something that's seeing a good amount of adoption. What this basically is a way for developers to describe in an abstract way what their service needs. So, hey, I have a Python service. It depends on a database of type Postgres, storage of type S3, DNS of type DNS. And then you have a connection string, how that workload connects to the database. And that's pretty much it. And the beauty is it's a single code format, and you don't need to think about local because you run SCORE compose and it converts to Docker compose. And you can send that through the CI pipeline, and then the platform will be able to actually generate the app and infrastructure configurations for the exact specific target infrastructure and environment. Now, there's also SCORE Helm, SCORE Compose, SCORE Cloud Run is coming in the GCP ecosystem. So this is something that's very, very helpful because developers can now focus on this. And this is what's driving this high degree of standardization. Delivery plane, we talked about this. And I want to skip this a little bit forward, looking at time here. So the sort of the dry run through that we're going to do is we're going to look at what happens if we're actually now, deploying something, we're sending something through that internal developer platform. The pulse, if you want, the rhythm of a platform is the deployment. With every single deployment is a chance for us to, fix what we screwed up, if we want to put it like this. And so, I like to follow the git push what now situation. Now, with every single git push, as a developer, we've applied a change to a service and we're sending this through the pipeline. Irrespective of whether there was a change to the workload specification and thus the architecture, the pipeline will also get the SCORE file or the workload specification. And it will receive this and it will then run through CI. CI will run the SCORE file already against an implementation to convert this into a format that the next step can read. So if you would be building your own orchestrator, for instance, to convert this into Helm, then you would run SCORE Helm, and that could then already, or some specific implementation could then already swallow this up and receive this. Now, this then hits the orchestrator. The orchestrator responds with an RMCD execution pattern, and that stands for read, match, create, deploy. And that's more or less for every orchestrator. I've seen the same pattern. I'm not sure whether people call it like this. I call it like this because there's no, convention. So in the read phase, the orchestrator just reads the abstract specification. In the match phase, it looks at the context by looking at the metadata, and it says, oh, okay, this is a deployment to an environment of type staging or any other matching criteria, test ID, env ID, whatever. And then it's matching this with the default baseline configurations provided by the platform engineers. The platform engineers would say, well, if you're just deploying to dev, please wire them up to this database. If you're spinning up a new environment, well, then probably create a new one, but don't make it too expensive. Do that in an existing instance. Could also be super complex things, but that's basically what you're putting in here. So they're looking at, okay, they're requesting a database of type Postgres. Okay, fine, let's do this. And then it's creating the app and infrastructure configuration. So app configurations first, and then infrastructure configurations. Then it's fetching the credentials. It's wiring everything up. And then, in our example here, it's literally creating the files and it's handing them over to Argo CD. And Argo CD is then going to execute and sync this. And we have our deployed application. That's pretty much what this is. This is what we call dynamic configuration management. And now I want to show you how you can use this to build golden paths. What are golden paths in that situation. And the first golden path that I want to look at is incredibly trivial. It's so trivial that you think, we've been doing this for years. What are you talking about? And that's from the developer perspective, a simple deployment to development. Every GitHub Actions can do that. There's nothing about this is special. I'm taking my workload specification in this case, and I'm getting the context from the metadata. And then it's hitting the orchestrator, and the orchestrator does its RMCD pattern. And in this case, very trivial, it's looking at this and it goes, well, environment to development, the Postgres is there, the S3 is there, the DNS is there. There's no update to the resource. So I'll just call the GCP API, I'll collect the credentials to make sure that they haven't changed. I'll, then register them in the secrets manager. Or associate this, and then I'm going to wire everything up, and now in the end everything is actually configured. We're still using the Amazon ones here, but this would be then GKE and CloudSQL. All right, so why should you care? What about it? This is special? Well, nothing for the developer. That's just business as usual for them. Nothing changes, but that's a good thing. The point is that if you are running this at larger scale, this is always a chance to now say, well, labels and annotations have changed under the hood. Change the baseline configurations, the system will automatically pull this in. You could say we're changing things to the APM sidecar containers. We are going to change horizontal pod auto scaling, and we're going to override this for test environments. So there are dozens of cases with every single deployment, on every single release, on every single service, we now have the chance to clean up. Let's look at another golden path here. We want to create a new environment. By definition, this is more of a side product. I'm not even a big fan of PR environments because, I don't know, people spend a huge amount of time implementing them. And then, I don't know, our colleagues, for instance, I'm not really seeing that used. But whatever, generally, by definition, if you're dynamically creating everything, you can also create a new environment. And this is the same procedure like a scaffolding use case. So, you have the exact same service, and that's the beauty in the developer experience. You take the same scroll file. You don't need to look at this again. It's absolutely straightforward because it's abstract. The only thing that changes is that you now say the context is that's in an ephemeral environment. It is the orchestrator that does read, match, create, deploy. Now, in this case, the orchestrator will say, wait, you want Postgres, and we don't know, like we know how to create one. So we'll go ahead and create one. And how the orchestrator is going to create this differs. Some people use some people call the Cloud API directly. Some people do it with Terraform, although then the orchestrator also needs to create a sidecar because you need that for CloudSQL in the Google case. And you do it with Pulumi or Crossplane, whatever. But this is how this would then actually happen. And then in the end, you have your new namespace and your new CloudSQL, in this case, file storage and DNS. Right, I want to look at one golden path from the platform engineering perspective. So let's say your CTO calls you and says, guys, I have a good day. I want to upgrade Postgres from version 14 to 15 across the entire estate. Now, today, you could go ahead and ask your developers to do that. And then you'll ask polite in the first week and less polite in the second week. And the third week, you'll shout at them. And then in the fourth week, you'll ask your CTO to shout at them. Now, in this world, it's slightly different because we now don't have 70 unique definitions of Postgres. We basically have 2, 3 across the entire estate. And the first thing you do is that you say, okay, what services depend on what resource definition, which is a simple call to the platform. And then the platform say, okay, well, that resource definition of Postgres has those 20 services depend on it. You go ahead, you update the resource definition and say, now it's version 15 and not 14. And then you enforce an update. You just call the orchestrator again, read, match, create, deploy, and the system updates all of them in the background and enforces the thing and rolls that out gracefully. So that's a classical golden path for developers. Now, the last thing that I want to do is actually show what it means to go off the golden path. Because if you think about the design principles that I was preaching, then you want to not take away context, and you want to give people clear guidance on how to leave the golden path. And there's another question with these platforms. I mean, you could now go ahead and say, okay, I'm guessing my developers need 3 roughly different configurations for Postgres, and then a couple for here. And that's another comment that the Bowl.com team made yesterday that resonated with me. You can't really estimate what your developers want, right? It's like estimating what your users want for features. And you can do that, but it's not really product management good practice. So I'm a big fan of letting these things grow decentrally, if you want, right? And so by allowing people to expand the path, build their own paths, if you want, you can actually do that. And then you can later decide, okay, that's a local path if you want. Do I make that global or not? Do I take that onto the global platform, or do I support this? Or is that just like a flink that one developer did? One example would be the developer says, I need a RangoDB. And a RangoDB is something that you never need until you need it. And then if there's no default, and they're literally sending the score file or do it in the UI and say, I need a RangoDB. And then the system says, that's good for you, but I have no idea what a RangoDB is. And then you can add a resource definition, hit the orchestrator, read, match, create, deploy. A RangoDB is there. And if the matching criteria are done, and the user has the role-based access control, right? That's important. If you're a bank, you probably don't want your users to just touch, I don't know, production grade configuration. But assuming that user has role-based access control, they can make that available for the next user that wants to do that. And that's what I call also standardization by design. Right, last thing that I actually want to hint at, because that was a little bit of an epiphany for me, is that platforming in the end is about clever structure of repositories more than anything else, right? You can rescue your entire setup by just really nailing how you structure repositories. In this world, there are certain repositories that are owned by the developer or by the product groups, and they contain the workload source code, the Docker file, and all of these things. Pipeline may be rather owned by the ops or platform team, that differs by context. And then you have the stuff that's owned by the platform, right? So those would be the resource definitions and the drivers and the infrastructure as code and the baseline configurations, workload profiles, automations, compliance things, all this. Now, if we think about the RangoDB case, what they basically do is that they send a new resource definition against the repository, and then the platform engineering team can say, you know what, a RangoDB, great, we are going to support this going forward. And they accept the pull request, maybe do a security screening before, and then this is available for the global group. And that's what's so powerful about this approach. Right, I'm going to stop right here and see whether there are any questions and whether there's anything that I can answer. And I hope I was a little more on time. It's still 38.
Yeah, thank you. Thank you, Kaspar. While we are waiting for questions, just to remind you guys, we'll send over the webinar replay as well as slides tomorrow, so you'll have it all handy, either to review later, to share with your colleagues. We'll also include the white paper that Kaspar mentioned, reference architectures itself on Google Cloud, and share it via email as well. If Google Cloud is not something you're working on, we also have an upcoming webinar on Azure in 2 weeks, I think June 15. That's the date, so you can sign up for this one later, as well as PlatformCon with McKinsey. I think it's going to be a very, very interesting talk.
Yes, and it's absolutely correct. One shouldn't use swear words, especially with my children sleeping in the next room. I'm going to get better.
But what was the word bullshit you said, or you said something?
I don't recall, but I'm going to look at the recording.
Okay.
Are there any questions? Anything that I can show or dive into? This is a lot of content, so you know, I totally understand it if it's slightly overwhelming and needs a second to get into and into the details. But anything that I can maybe deep dive on?
We have a question. How do you get devs on board with a new paradigm?
With a new paradigm?
Mm-hmm.
So yeah, so I think the first important thing is that you get them on board, right? So I think the first thing that many get wrong is that they don't involve the developers. I think the tension is a little bit that what's good for the organization doesn't necessarily mean it's good for the end user and for the developer. You know, you might be in a world where your central operation teams are completely overwhelmed because they get so many requests. But if you really look from the perspective of the developer, they're sending a Slack request or whatever, and maybe that's fine for them, right? You know, they don't feel the pain that other teams might be feeling. That doesn't only hold true for those two personas. Also, the security teams are often incredibly stressed because they have to look at everything. It would be much, much better for them. Very often, it's a perspective thing. So the users we deal with aren't stupid. They totally understand if if something is not healthy for other parts of the organization. But we need to explain that, and we need to put that into perspective and really talk to them. Now, if I'm looking at the paradigm shift, the answer is the adoption speed depends on where you come from. If you come from a compliance-heavy environment, you know, you're a bank or healthcare or whatever, and your alternative is to wait 3 weeks until you have something new or something gets debugged, then the adoption curve is very high. If you are in a hipster startup in New Delhi and you're used to move ultra fast and break things, then it's more likely that your developers will feel restricted and it will be a heavier lift. In general, those workload specifications are things that people pick up in 20 minutes. So it's not a technical lift. It's not difficult to get people trained on this. It is making sure that you really communicate. And while you're designing the platform, they are in the room. That's very, very important.
Cool. Next question from Arthur. What are the challenges in adopting IDP across the org?
Well, I think it's that what I just said. I think that this definitely counts into this a lot. I think it's important to not even think about this across the org from day one. Another great comment from somebody at Mercado Libre yesterday, Giuliano, that platforms should not actually intend to cover 100%, because you'll not be able to do that. There is a reason why there is no commercial offering that offers you cross-cutting platform functionalities across VM, Kubernetes, and serverless, because it's just such a complex lift. Now, you should focus on the lowest common tech denominator, and you should do 80% well, but 20% of your developer population will always go off and do their own stuff. And that is a pretty consistent number. Mercado Libre, same thing for them, if I recall this correctly. Now, you just embrace this. How do you do the adoption? You do it by pull, not put, if you want, right? You want developers, you want to offer something, and you want to be able to convince the users to actually to join in, because what you're offering is a step function better than what they're using today. And that's why you want to bring on the first team, and they're your lighthouse customers, and you really focus on them a little too long. And then once you really win them, then they become your advocates. I'm really warning teams to do big bang, large scale rollouts across thousands of developers at a short period of time. That's not very often working.
Yes. You mentioned that you didn't find value in developer portal with organizations that have fewer than 200 engineers. Can you expand on that?
Well, I want to be careful with definitive statements. It can make a ton of sense. So we need to think, what's the value that portals provide? They give you visibility. Now, the question is always, how do you quantify visibility? What is faster or better after you see it, right? Now, that's a question to ask yourself. And the second thing they do well is the scaffolding use case. So if you're creating an incredible amount of microservices, your Spotify, for instance, does it make sense to have a great portal? Absolutely makes sense, yeah. If you're creating a new microservice once a month and you can improve that by 10 minutes, does that really, really, really change something? That's the thing that I would ask myself. But I think you cannot, and I cannot make absolute statements on this. It always needs to be a return on investment calculation. You sit down, you say, okay, against 100 deployments, how often do we do certain things? If a developer deploys 100 times, how often are they creating a new service in those 100 deployments? How often do they roll back? How often do they add a new resource? How often do they add an environment variable? Like all of these things. And then you force rank, you multiply times the number of deployments, you multiply probably times the hourly wage of your colleagues. And then you have a pretty good prioritization schema, and that can help you make the decision. Now, if the answer is visibility makes the difference, then go ahead. Many people use that, and that might make sense as well. That's a totally valid reason, because it's easier to sell that to managers as a starting point. They look at this and it's something they can feel and see, and it's tangible, and that's why it's easier to get budgets for that. That's also a reason. So the reasons differ. I'm wondering whether at the scale of 200 developers is returning the same, the good return on investment. If you look at, Backstage website, for instance, and I love them dearly, right? If you look at their repositories, they explicitly say that. So, I think we're pretty aligned there as an industry.
Are there any plans to offer local support for the RMCD workflow? Turning the score file into resources can be run on a laptop versus in the cloud.
Local support for the RMCD workflow, turning the score for a laptop in the cloud. Yeah, okay. Yeah, so you don't need an RMCD complex orchestrator for that. You can just go in score, and then you just use the score compose CLI, and it will automatically do this. I know of a team that's just building more templates for this to make that workflow more seamless, but that's working fine today. You don't need any other tool. That the open source solution should be totally fine.
And to read more about RMCD workflow, what's the best resource you would go into?
The white paper, probably.
white paper. Yeah, we'll share the white paper. I can put in the chat right now with the form. Next question from Ricardo. Can you comment on the use of feature flags and where in this blueprint will fit? Is it just treated as application config? Who are responsible for this, devs or platform engineering? So 3 questions.
Yeah, that's a great question. So yeah, that would probably be something that you would integrate, you know, in or after the deployment phase, where you would then have a, you know, feature flagging mechanism to run tests against this or to flag certain features. And that's something that I don't see a clear differentiation where that usually sits. So in our engineering case, for instance, it sits with the QA teams in combination with the developers, but that differs wildly. Yeah. It would be actually, that's an interesting thing. There are a number of these specific things in the workflow that are not represented in those reference architectures that we should consider in the next iteration.
Cool. Next question, will you elaborate functions in the monitoring and logging plane as well as the security plane?
Functions. So if we start with the security plane, I mean, the most obvious is the secrets management, just to make sure that we're securely dealing with credentials, that we deal with value versioning. So if you want to do dynamic configuration management right, and that's a tough one to pull off, then you want to version the values as well. And so versioning, value management, secrets management, rotation, all of that on the secrets management element. And then on this, there are more elements to the security plane, right? Depending on your security posture, the enterprise often requires to have the output of the platform back-checked by another system, either by another system or by human beings, really, right? Any release in the financial world that goes to production would go through a consistency check or compliance check. And if that would also be part of the security plan. That's another thing that at enterprise scale, we should probably add to that reference architecture. And then there's also the human element. So the system needs to be able to have pre and post deployment webhooks to basically put things on hold and then send requests to third-party systems or actually humans, let's say ServiceNow tickets that get surfaced to security teams. And only if those things are confirmed automatically or by a human, then the deployment can proceed. So that's definitely also in the security plane. And then on the APM, I mean, you have logging, you have the general observability elements. The question is, if you think about this, in these systems, you have logs from several places, right? You have the actual container logs, for instance. You have also resource error messages. I don't know, there is a crash loop or whatever, and that produces errors. You have errors from the resources. You have errors from the systems further down, compliance systems. You have errors from Argo CD, for instance, right? Deployment errors. So all of that log aggregation, error messaging needs to be channeled and surfaced well. And that's very important on the interface design, because you need to make it easily accessible for the user. And where you surface this doesn't, could be in APM or dashboards or whatever, but that needs to be consolidated in order to make for a consistent experience.
Cool. And the last question from Luis. basically, the platform orchestrator is the centerpiece where the platform team hands off the cognitive load of how to make sense of what the team needs. It sounds like a good starting point is the use of repo templates consumed at the CI stage if we are only considering golden path. I guess it's more of the statement I want you to comment on.
Yeah, so yeah. As I said, I mean, I want to say one more thing. You cannot solve your organization's problems with neither fancy reference architectures nor fancy tools. So I think the starting point is probably sort of a cultural conversation. Second, in the end, it comes down to repository structure and management and a clever way of thinking about role-based access control in a way that doesn't hinder people. And how you then execute these things, if you build, if you simulate orchestrator capabilities through side pipelines or however you do it, that's the sort of the second step if you want. But yeah, that definitely makes sense.
Cool. Thank you so much, Kaspar. Will you be speaking at PlatformCon as well? What will you speak about?
I will have one talk about designing golden paths, and I'm going to look at more examples. I think it's called Designing Golden Paths for Day 50, not Day 0. An incredibly attractive title. And I would probably not join this talk if I were you, because you've seen a lot now. I would join. So there's a fantastic talk by Niels around testing platforms, which I find fascinating. I would look at Gregor Hope's talk about clever abstractions, and I would consider the McKinsey talks as well, because those are the guys that have built this. Then there are like Bol.com has interesting talks, Mercado Libre as well. So if you want to hear from those practitioners directly, that's definitely something to watch out for. In general, I think it's a great event, and it's if you're in, I think in San Francisco and in Austin and in Barcelona and in London and other places in the world, some people have organized watch parties.
Yes.
So that I think is definitely something to go there and drink a couple of beers.
Yes, let me put in the watch party links right in the chat as well here. So guys, if you are in one of those cities, or I also know of examples where companies organize watch parties just for their like internal engineers, employees, which could also be a great idea for your internal, beers and connect party with your colleagues. But cool, I think that's either one in Berlin. I wanted to do one, but nobody supported me. So Kaspar, next time we're hosting one in your house, okay?
Yeah, there's no in Berlin. Yeah, it's strange that we don't have anything in Berlin yet. So next time we can. I live outside of Berlin, to be honest, on the countryside. If you want to come outside, you're always invited.
Yeah, you'll have a big projector. I can actually see it. So we'll do in your house. Cool. Thank you all for joining. Hope you have a great rest of the day or end of the day. And we'll see you at PlatformCon. Hopefully, if not, as I mentioned, there is another webinar on Azure. But hope you enjoyed the talk, and